so continuing with our constant velocity problems, we're just going to go ahead and solve this whole thing. So we have a problem with, well, we got our displacement of 330 kilometers in 4.25 hours. So let's get that velocity. So the velocity is going to be delta x over time, which is going to be 330 kilometers over 4.25 hours. So let's go ahead and calculate that. And we end up getting 77.67 or 65 meters per second. The only difference between speed and velocity here is we need a direction for velocity. So the numbers are the same. Now here we go. A bird can fly 25 kilometers an hour. How long does it take to fly 25 kilometers? So let's see. So our displacement is 18 kilometers. And we know that our velocity is 25 kilometers per hour. So we know that delta x is v naught times t. So at the time, we're going to take delta x divided by v naught to get t. So that's going to be 18 divided by 25. And when we get that, we end up getting 0.72 hours. Or if you want to multiply by 60, that would give us 43.2 minutes. All right. So I guess that would be 43 minutes and 12 seconds. So let's see. You are driving at 110 kilometers an hour, and you look to the side of the road to talk to a friend for 2.5 seconds. How far would you travel during this careless period? So we're going to convert the time from seconds into hours. So let's be very clear here what's going on. We want to say here that we have a v naught, which is 110, and that's kilometers per hour. And we have a time, which is 2.5 seconds. But to get delta x, the displacement, that's going to be v naught times t. So we're going to do delta x equals 110 kilometers per hour. Now we want to multiply it by 2.5 seconds, but we're going to be careful. We actually need to convert that. So let me go ahead and do that conversion down here. So we will have 2.5 seconds times 1 hour over 3,600 seconds when we do that conversion. So when we do that, that's 2.5 divided by 3,600, and that gives us 0.00069 seconds. And absolutely sure, but it looks like we are actually moving 0.07 kilometers. But when you times that by 1,000 to get meters, wow, that's like 0.076 kilometers. We times it by 1,000, it actually ends up being 76 meters, which is like 3/4 of a football field. And 110 kilometers an hour is kind of like 65 miles, a little over 65 miles an hour, 70 miles an hour. So you're going to be careful when you're driving quickly. All right. So let's take a look at this next problem. So we have a person jogging around a track, 400 meters in total, 130.5 minutes. What's the distance that they ran? So 400-meter track. Let's assume that the track is 400 meters in circumference. So if we do 8 complete laps, that's 8 times 400, which is 3,200 meters. Since they started and ended in the same place, their displacement is 0. So that means the average velocity is 0 if we skip down here. Now the average speed, that's going to be distances rate times time, which is, again, rate equals distance over time. We plug that in, that'll be 3,200. Divided by, and this is going to be in meters per minute. So that's going to give us 237 meters per minute when we do that conversion. Excellent. So problem number 5. Oh boy, here we go. First, we get a horse cantering away from its trainer in a straight line, moving 150 meters away. Turns around, gallops back. And we say away from the trainer is a positive direction. So here's the trainer. We'll start that out at the origin. So the horse goes all the way out to 150 meters and then gallops halfway back to 75 meters. So let's kind of be clear. To make it all the way out here, it does so in 14 seconds. And then it gallops back in 4.5 seconds. So we've got a little bit of work to do. So we're going to get its average speed. So the total distance is 150 meters forward plus 75 meters back, because that's half of 150. So that's 225 meters for distance. Okay. So its average speed is going to be 225 meters divided by 18.5 seconds, because I'm adding up my 2 times. So that's 225 divided by 18.5. So these videos seem to be going a little quick for you. You need to pause and kind of keep up with the calculation. So this isn't the kind of video where you can just watch and passively get it. You're going to actually have to do a little bit of work with these and do some thinking. So it's 12.16 meters per second. So you need to ask somebody else. You need to watch the video a couple times and kind of follow along with what's going on. So this is the speed. Now, if we want to get the average velocity, that's going to be delta x over t. Well, my displacement, my x final is 75, my x initial is 0, so that's going to be 75 divided by 18.5 seconds. So 75 divided by 18.5 gives me 4.05 meters per second. And that would be away from the trainer. All right? So there's that one. All right, problem number 6 is actually quite a little tricky one. So let's be careful. We have a person starting at home, and then they go 200 kilometers out. So we go from here to 200 kilometers out. Then they wait, and then they go back home. So right away, let's just get one thing out of the way right now. Average velocity of the complete round trip. The average velocity is 0 kilometers per hour. The trick for this is getting the speed for the round trip. So first, let's get the distance. The distance is going to be 200 kilometers there plus 200 kilometers back, which is going to be 400 kilometers. Now, to get the speed, distance is rate times time, or distance over time equals rate. Now, here's the problem. To get the time is going to be, this is the tricky part, my time in this problem is going to be the time there plus the time for lunch plus the time back. And I have to calculate that using the numbers that they give me here. So what this means is we actually split this into 2 problems. We're going to do 2 speed problems. We're going to get the time to go there, and then we're going to get the time to go back using distance equals rate times time. So to get the time there, I'm going to say rate there equals distance there over time there. And so I know the rate is 90 kilometers an hour, and that equals 200 divided by the time there. When we arrange, we're going to get the time there equals 200 over 90, and that ends up being 2.2 hours. Okay, so the time there is 2.2. And let's remember the time for lunch is 1 hour, because they gave us that in the problem. So now we need to get the time back. So we'll do the time back, we'll do that calculation over here. So the time back, rate back equals distance back over time back. Sorry, there's another way to arrange that formula, I realize that. So we'll get the time back is distance back over rate back. And that's going to end up being 200 divided by 50 for the rate back. So that gives us 4 hours. So I'm going to put 4 right there. This means my total time there ends up being 5 plus 2.2, which is 7.2. So my rate, my speed there ends up being 400 kilometers divided by the 7.2 hours it took me to get there. So let me go ahead and calculate that. And what we'll end up getting is 400 over 7.2, which is an average rate of 55.6 kilometers per hour. Okay, so that's that one. All right. This is just more of the same. Now, what I'm going to recommend you do is actually practice these on these next 2 pages. I'd like to see you practice them on your own. So I may put solutions into Dropbox, but I do not want to vodcast these problems because I want you to get some practice in not seeing solutions, just so you're sort of forced to think about it that way.